Good morning and good afternoon for those of us spread across the U.S. today. Thank you for joining us, taking some time out of your busy days. And we're here to talk and be joined by Aero Barrier's own Troy Wilbanks, talking about tightening the envelope with air sealing. So Aero Barrier, for all of you who aren't aware, air sealing technology that we're going to dive into here in a little bit, but really changing the landscape and changing how architects and project managers and builders can really think through their process. Some housekeeping items for today. The presentation is being recorded. Feel free to ask questions throughout, and we'll get to those questions at a later time. Feel free to also add in your AIA numbers to the question box, just in case you don't fill out the survey or something later on, that we can get those learning units awarded to you. And then there will be a short survey towards the end of this once we close up shop. 5-6 questions, just letting us know how we did, and then also an opportunity to enter in that AIA number. Without further ado, I will pass this over to Troy and we'll get right to it.
Perfect. Thank you, Billy. Yeah, as he said, my name is Troy Wilbanks. I'm the National Sales Manager for Aero Barrier. I work with builders, architects, trades, GCs, PMs, really everybody across the board with a focus on air sealing, not only on single family detached, but definitely in the multifamily and commercial world as well. So today the presentation is going to be set up in a kind of a traditional AIA format where we're going to be it's going to be educational for about 80% of the presentation, and at the end we'll hop in a little bit about explaining what we do here at Aero Barrier. So to set expectations at the beginning of the presentation, we're going to go over understanding the importance of air sealing and get some kind of housekeeping items out there, some of the most common questions that I get straight out of the gate, and then move forward to the benefits of air sealing, and also touch on the challenges of air sealing. Then there's a slide that I have that's air sealing moving forward, which is kind of a list of recommendations and best practices that I've received from various different folks that I've been working with. Really compiled that into a list, and hopefully it adds some value for you. And then at the end, like I said, we'll talk a little bit about what we do here at Aero Barrier. So, why are we all here today, right? Why is air sealing so important? Well, really, arguably, can have the single greatest impact on any build when it comes from design all the way to occupancy. So we're talking about not only meeting blower door requirements or meeting code LEED requirements, passive house, net zero, whatever that may be, but how it affects the actual build, the construction of the project, as well as the main intent, which is the end environment for the occupant, whether it's going to be a house, an apartment, a school, a hospital. Air sealing has a major impact and extremely important when we're talking about indoor air quality for those occupants, reducing their energy bills, giving them a more comfortable environment to do whatever that building is designed to do, right? So kind of moving on to some of the setting the framework moving forward. I wanted to just discuss where we really come in the view of building science and risk management. So we have the four control layers, and the first thing we want to mitigate against in any design for any project is going to be bulk moisture. Bulk moisture can negatively impact a build just about faster than anything short of intentional human action. Then we come in with airflow. It is extremely important. That's why it's listed as number 2. A lot of people in the building science world really believe it should be a 1.2 because of its impact on the thermal control. And with that, we're talking about insulation and mechanicals, as well as its impact on the moisture and vapor control. And I have a couple slides where I'll go over that as well. I do want to take 1 second and kind of define our focus. So when most people are thinking about air sealing, their mind tends to drift to 2 areas. One is going to be your external area. We're familiar with these. These are the OSBs, WRBs, Tyvek zip systems, blue skin, fluid applied barriers. Extremely important, especially in mitigating that bulk water, which we were talking about a second ago. These are very important, important enough that, really one trade typically is tasked with installing them. And there's actually, individuals, some may be attending today, that have devoted, their entire career or a large portion of their career to focusing on these external barriers and consulting on them, and rightfully so. Then there's the other area, which is the internal air barrier. And that's kind of what we should be thinking about today during this presentation. That's what most of the information is going to be tailored around. The reason why we do that for this presentation is because those internal air barriers are extremely complex. They're, systems that are comprised of various different components: drywalls, caulks, tapes, foams, membranes. And in each code, it basically says, that there needs to be a continuous air barrier. So what does that mean? And what are some of the benefits of it? Why is the code pushing for tighter and tighter building envelopes? Also, dealing with the complexity of that internal barrier, not only the components involved, but the amount of trades that are involved in it, right? Each person kind of has a secondary scope of their work that is focused on air sealing, and we'll dive into that a little bit more here in a minute. I get this question a lot: how tight is tight enough? And I think that this question comes from the fact that codes across the United States, as well as different requirements for certifications, are getting more strict, requiring tighter and tighter building envelopes. But my answer to this, how tight is tight enough, is relatively simple. We want all buildings to be as tight as possible, with really three things in mind when we're designing our air sealing strategy. One is going to be compliance. This is the most basic. Are we going to meet code? Whether it's your basic IECC code, or whether we're getting into more stringent codes, Passive House, Net Zero, Energy Star, LEED, those types of certifications. Is our air sealing detail going to meet that compliance requirement? And how are we going to do that? That's definitely the first thing we need to keep in mind when thinking how tight is tight enough. Also, impacts on mechanical equipment and the insulation. So with this, what I mean is, if we're designing our air sealing strategy in for a build, and requirement is, let's say, 5 air changes. If it's 5 ACH, and that's what the building is being designed for, but we come in with an aggressive air sealing detail that gets us to 2, well, those mechanicals aren't going to operate the way that they should, and the occupant isn't going to get that comfortable environment that the building was designed for. So definitely keep that in mind. Obviously, the inverse is true. If it's an environment where we'll say it's still 5 air changes per hour and you come in at 7, well, the mechanicals aren't going to operate as designed, and you're honestly not going to pass your blower door requirements either. But so definitely keep that in mind when designing an air sealing strategy. And then also the building owner's goals. This is becoming more and more important, specifically when we're talking about air sealing. Obviously, the building owner's goals is going to be comprised of the first two, the compliance and the mechanicals. That's a given. But also, what other things can proper air sealing or aggressive air sealing impact? And what we're talking about is, can it reduce warranty complaints? Can it reduce tenant complaints? Can it reduce tenant turnover? And there's a lot of these aspects of air sealing that can really impact various different building owners' goals, including allowing them to capitalize on different tax incentive and rebates. And we'll get into that here in a little bit. But building owners' goals are extremely important when we're talking about designing air sealing strategy, not only to meet code, but also, can we reduce tenant turnover? Can we reduce warranty complaints? Can we reduce the size of the mechanical equipment? We'll go into that a little bit deeper here later on in the presentation. But typically, following on the coattails of that, how tight is tight enough? I get asked the question a lot: could a building be too tight? And as I said earlier, we want all buildings to be as tight as possible, but designed for appropriately. So what we're really seeing is, once we're getting down to that 1.5 to 2 air changes per hour, is when a building is tight enough that we do need to add air recovery units, because a building does need to breathe, but it needs to breathe properly, right? So these HRVs and ERVs, they're fantastic. They will bring in the exact amount of CFM needed for that building to operate as a system. but it's not just bringing in that potentially contaminated outside air with pollen, different smells, smoke as we have out west. It conditions that air as it brings it in, so it's not going to diminish your indoor air quality. All right, now we're going to hop into some of the benefits of reduced air leakage, and there are definitely a lot. The first one that I'll touch on here is the reduction in heating and cooling bills. This is big. This is really big. Obviously, common sense tells us, in the summer, if we can keep that, that cooler, conditioned air inside and not have it leak out, and in the winter, keep that warmer air inside and have it not leak out, your mechanicals aren't going to have to run as much. You're going to reduce your energy bill. It's definitely one of the key factors in why codes are getting stricter, right? On top of that, we're reducing our demand on our utility companies and really just, reducing carbon footprint in general. Then, moving past that is the benefits for the end occupant. Having a more comfortable home, having a more comfortable working environment with fewer drafts, fewer temperature changes, preventing outside noise from entering. Proper air sealing can actually reduce sound transfer up to 40%. Typically, we're talking about those higher frequency sounds, conversations, TVs, babies crying, things of that nature. I bet it reduce those up to 40%. Also, if we're properly air sealing, there are no gaps for insects or pests to get through. Obviously, they can't get in, and this is extremely important when we're talking about the multifamily world, right? I've lived in quite a few apartments in my life, and I can tell you that not everybody has the same taste in music, in cleaning, and in cooking. So being able to prevent outside noise from coming in, insects from coming in, as well as odor transfer is a huge benefit to everybody, really, in the single-family detached world or in the multifamily world. There's also some benefits for the builder and the building owner, which I'll get into a little bit more detail here in a minute. One of the key benefits, and I know a lot of people out here have probably seen this slide though, of proper air sealing is moisture control and its impact on moisture control. So, we have this nice visual here, really explains the difference between vapor diffusion and air leakage and the impact that air leakage has. So on the left-hand side, we have a typical wall system, and over about a month, about a third of quart of water enters that wall system and it dries out. They're designed to do that, no harm, no foul. Then on the right-hand side, we see what happens when we introduce air leakage. So in that same period of time, in that same 1 month time, when we introduce a 1 square inch hole to that wall system, the game changes. It goes from a third of quart of water entering the build to 30 quarts of water. Obviously, that can have a negative impact when we're talking about potential mold and mildew and wood rot. The opposite is also true, and it's a huge benefit. If we can eliminate that square inch hole, it's going to prevent those 30 quarts of water from entering that build. And when we're thinking about that 1 square inch hole, you can think of it as taking a jigsaw and cutting out a hole. But in real life, what we're really saying is this is just an accumulation of numerous leak points, cracks, holes, crevices, people, areas where the trades missed part of their air sealing detail. That adds up to a 1 square inch hole. So that's really what we're seeing in the real world. The benefits of air sealing and protecting the integrity of the build. We just talked a little bit about the difference between vapor diffusion and air leakage and helping prevent that water from that water vapor from entering. I really like this slide though, especially when we're talking about the integrity of the build. Obviously, the point of this slide is to show how condensation occurs and how proper air sealing can prevent that. That's the obvious one. So we'll walk through that here real quick. We have the warm moist air on the inside. You see that leak point down at the bottom. That warm moist air is entering the wall system and it's hitting that exterior wall, that sheathing, which is cooler. So that warm moist air is then going to condense into water and really cause some potential issues in that wall system. Mold, mildew, wood rot, those type things. That is pretty obvious. So sealing that up is going to prevent that from happening. Another thing that I really like about this slide is the not so obvious. So, what is this air leakage doing to that insulation, right? So insulation, the R value is derived in a lab type setting where everything's completely controlled. Once we hit the real world, that's not the case. So as that air is moving through that wall system, it's really going to reduce the R value of that insulation substantially. So the end occupant is not getting the benefit of the specified product. So, you know, by preventing that from happening, you know, are we going to give the occupant, you know, a more comfortable environment? And the answer is overwhelmingly yes. Also, you know, in this process of saying, okay, you know, can we prevent this from happening? It's going to allow us in the design phase to take a look at more economic insulation packages. You know, lots of times people are going with a much higher R value with the anticipation of some air leakage. But if we can prevent that and guarantee that, you know, it gives us more economical options, you know, in the beginning. This is a big one, and you'll hear me say it a lot. This is, you know, why code is being pushed to such strict levels, and it's really to prevent energy loss. So, you know, study after study shows, excuse me, that air leakage is either the primary or the secondary culprit of energy loss. So, you know, what can we do by properly, you know, air sealing? You know, can we take that 30%, you know, down to 20%, down to 10%, down to 5%, and really reduce that heat loss or energy loss, reduce individuals' energy bills? And we're finding definitely that the answer is yes. And I really like these studies because most people, if you would ask them where they think most you know, heat loss occurs, they would say, you know, windows and doors. And I think it's because just in our daily lives, you know, that's where we have felt drafts. But really, you know, the primary or secondary culprit is going to be air leakage, and that's in the form of those real small, hard to find cracks, holes, and crevices that people, you know, can miss in an air sealing detail. Well, actually, the installation, but you know, by preventing that from happening, you know, we can have really a lot of positive effects for the end occupant. I do want to take a second and talk about the benefits of a consistent and aggressive air sealing strategy when we're talking about the design build phase. So, you know, what can this detail, you know, what can it impact? Obviously, you know, as we talked about before, we're going to meet that compliance level. You know, we want to hit that, you know, that code, whatever that may be. But, you know, going further, how can it impact the build? What are the butterfly effects of air sealing? And there's a lot. So, you know, using the example that I had earlier, you know, if we're in an area where it's 5 air changes per hour, and that's what we're trying to hit as far as code, what happens if we say, hey, we're going to get really aggressive, we're going to come in at 2 air changes? You know, well, what we're seeing is that's going to reduce the size of your mechanical equipment. That's going to reduce the size of your ductwork and your vents. Going to reduce the capital expenditure up front. It's also, with smaller mechanicals, it's going to help further reduce the owner's energy bills. So this is, you know, a very, very important thing when we're talking about, you know, the single family detached world. But, you know, numbers do multiply. So if it's the single family detached world and you're, you know, building 50, 100, 200, you know, 1,000 houses, these numbers add up. Same thing in the multifamily world. If we can reduce, you know, tonnage in a 100 unit build, you know, that is going to really add up. Also, warranty complaints. We touched on that a little bit earlier, but by preventing water vapor from getting in, you know, it's going to prevent that mold and mildew and potential wood rot and various other types of warranty complaints. So addressing this air sealing in the design build phase can definitely impact that. Also, the existing building products. I kind of hit on this, so I won't harp on it too much here. But, you know, the butterfly effects of a aggressive air sealing strategy, you know, do impact those mechanicals. They do give us more options for insulation. Actually, they can really impact the external barrier, you know, through energy modeling. If we say, hey, we're going to guarantee, you know, 2 air changes an hour, you know, how can that impact the external barrier? Can we go with a more economical option and get the same or improved building performance, right? Tax incentive and rebates, I'll go over 2 of those here in a second. Grab your pens, they're really important, and I like to talk about them. And then there's the build process and improvements in the build process, really just in the beginning, if we're defining an aggressive air sealing strategy, labeling the who, what, when, where, why, and how of who's doing what as far as their scope of work for air sealing. It's going to, reduce times, improve schedules, reduce costs when it comes to time and material with labor and air sealing products. So definitely a lot of benefits in the design build phase. And here's the slide that I was talking about with the financial incentives. I like to talk about these because they're out there and not a lot of people know about them. A lot fewer than I originally thought, but it makes sense. If you're looking for a tax incentive or a rebate, normally we're talking to our municipality, our utility provider, a manufacturer looking for manufacturer's rebates. These are actually offered through the Fed, through the IRS, and not a lot of people are diving into tax code to take a look at potential rebates for a build. So I'll highlight them here for you. The 45L, that's going to be for residential. It says home, but that word home it actually is used for really any place that people are going to be living. So we're talking about senior living, student housing, low-income housing, market rate apartments, luxury apartments, really anywhere where people are going to be living. And it's, as I had mentioned, I like to talk about this because there's a lot of people that are already meeting this and not realizing it's there, not capitalizing on it, or they need to change a couple things and then they can capitalize on it. And it's because the requirement is exceeding the 2006 ICC code by 50%. That's an old code. So, a lot of people, like I said, are already almost capitalizing on this or need to change a couple things, and they can. This could be you, this could be your clients. But there's a lot of money out there. So the 45L is $2,000 per unit, if you will. So simple math, an apartment complex with 100 units, that's $200,000. That's not a small chunk of change. The 179D is very similar to the 45L, except it's more commercial. So we're talking 4 stories and up. And instead of per unit, it's based on tax deduction up to $1.80 per square foot, which can definitely add up. Now we'll hop into some of the challenges with air sealing, and there's a lot, but I'll go over the main ones that I hear about. First and foremost is the trades. I hear about this a lot, and this is nothing negative about the trades, right? I don't want anybody to feel like I'm harping on them in this presentation because the trades are good at what they do. They take a lot of pride in what they do. But air sealing is often seen as a box to check or a secondary aspect of their scope of work. An electrician didn't become an electrician with the vision of walking around on a job site with a can of caulk any more than I'm sure any of you became architects or builders with the vision of sitting here listening to me talk about air sealing, right? So it's really not their primary scope of work. And if something isn't your primary scope, you're not going to give as much attention. Also, there's a lot of trades involved. Everybody has their own aspect of air sealing. More people that are involved, the more complex the project, the longer a project goes, it's just natural, opens up more room for mistakes, right? Materials involved, this is huge. What works, what doesn't, in what combination, in what climate. Is it humid? Will work in a humid environment, a cold environment, windy environment? I mean, I'm sure we've all gone through this exercise before, and it's a challenge. But overall, getting it right matters. Getting it right matters a lot. Not only are we talking about being able to pass our blower door requirements or meet that code so we can get our COs. There's also tax incentive and rebates associated with that. And then going much further than that into the future of providing those in occupants with all the benefits that we talked about earlier. Reducing their bills, providing them better indoor air quality. For the owners, talking about reducing tenant turnover in the long run, reducing complaints. So getting it right matters, and there's a lot of butterfly effects that I talk about in a positive manner. And if you don't get it right, those butterfly effects can definitely take a negative turn as well. Want to talk about the multifamily world here for a minute. Demising walls are party walls are a huge challenge. Not only are they a challenge to design, there's a lot of ductwork, piping, a lot of stuff going through these walls, lots of penetrations, but they're hard to install, and definitely hard to air seal. I mean, extremely hard to air seal. One of the reasons is, yeah, there's a lot of penetrations and they're difficult to design, but they don't get the benefit, the full benefit of that external barrier that we were talking about earlier. So if you can imagine, we've spent a lot of time, attention, invested a lot of money, selected the right trade for the install for our external barrier. And they install it, everything goes perfect. But in a multifamily world, that corner unit is going to receive the benefit of that external barrier on two sides. The room right next to it is only going to receive that benefit on one. So one of the primary things we invested in and designed for, that external barrier isn't benefiting all the units, in the same way. So it can definitely pose some challenges. Keeping up with the code, this is also a big one. As we know, codes are constantly changing. If you work in one market, that's great. It's still kind of not hard to keep track of if you're working in one market, but keeping a track of when it's going to change and accounting for that. If we're going from 5 air changes to 3 air changes, what is our air sealing strategy? What's our detail? How are we going to meet that? And then if your clients or if you are building on a regional or national basis, it's very hard, and designing a different air sealing strategy for each project. It's time consuming. There's a lot of labor involved. And oftentimes it can be, kind of like reinventing the wheel. And codes are getting stricter. They're changing across the United States. I know Virginia is going to 5 ACH with blower door tests required. Tennessee, Davidson County just went to 3 ACH with blower door required. Parts of Georgia, Atlanta is now 3 air changes with blower doors required. And then you got Colorado, where there is no state requirement, if you will, but each municipality gets to define their own. So, Denver is going to have 3 air changes, where other cities may not. So keeping track of this and designing accordingly can be a challenge in and of itself. And then all in all, the human factor. This is huge. If you've ever been on site when a blower door test has failed, this quote from an anonymous person here really rings true. To make mistakes is human, but to blame it on someone else, that's even more human. And like I said earlier, it's just the nature of what goes on. A lot of people involved in these projects. It's not everybody's, it's really nobody's primary scope of work for air sealing. And mistakes can be made. So when that blower door test is failed, everybody just kind of starts pointing at one another, right? And it's difficult to manage. I mean, if you flip on if you flip a light switch and the light doesn't come on, well, you call the electrician. If the roof's leaking, you call the roofer. If you're not meeting blower door requirements, who do we call? Typically, we're gonna do an all hands on deck type thing. Get our drywallers, our electricians, our insulation crews back out, ask them what they did as far as air sealing, and then work backwards from there, really trying to fix whatever problem there was at hand. And it can be extremely, extremely difficult. So what's the solution moving forward? And this is the section that I talked about earlier, where I have taken some of the recommendations and best practices from various different architects, GCs, and trades that I've worked with, and kind of put them together here, and hopefully everybody can get some value out of this. So the number one thing that I hear about when I have these discussions is we're all on the same team. It might not always feel like it. We're humans. There can be disagreements, differing opinions, but we are all on the same team. We want to be a part of projects that we're proud of, that we can, once they're completed, we can look at and know that they are going to perform and provide an environment for the occupants to do whatever that building was designed to do, whether they're living there, going to school there, whether it's receiving medical care there. We want to be a part of a project that we're proud of. It looks great, it performs great, and we know that it's going to be a comfortable place for those individuals. So, how can we transition that to the topic of air sealing, which is, so can be such a nebulous, concept of because we're literally chasing air. It's hard to do. But the number one thing that I hear is, defining a goal, in the design phase, as early as possible, and really communicating that across all parties. The quicker things can be addressed, the more it's communicated, the importance of it is communicated, the better things go. What I mean by that is, in the example we were talking about earlier, let's say it's 5 air changes, and we say we're going to get aggressive and we're going to come in at 2. That's going to be our goal. And the reason is it's going to reduce the mechanicals. It's going to, reduce the insulation package. It's going to, improve time and material cost. And then in the end, when the occupant lives there, or what does they lives there, we're going to know that they're going to have a better environment. We're not going to have, a lot of moist air entering the build. We're going to have standardized kind of temperatures, not a lot of temperature fluctuation, or wind or drafts. And really that's why we're doing this. And communicate that, throughout your team, through the GCs, through the trades, through everybody. Let everybody know that, air sealing on this project is not just a box to check. It is everybody's primary scope of work. Especially with the trades, if they look at it like it's their primary scope of work, they're going to pay more attention naturally, and they're going to execute it, and they're going to execute it well. Right along with that is developing that detail, and include accountability in there. Accountability can sometimes be thought of it in a negative connotation, but I don't mean it in a negative connotation at all. Really in a positive way. Some of the real high performing GCs that I worked with and PMs, if somebody's doing a really good job, man, they put their name up in lights. They really do. And who doesn't like that? So utilizing positive reinforcement, especially for something like air sealing, can really, take the trades and the project and the performance a long way. And educating the trades, letting them educate you. So, when I say educate the trades, kind of goes back to that first thing, communicating your air sealing detail and the importance, across all parties that are involved. And have them look at the drawings, look at, hey, this is the design, here's the continuous air barrier, and really just educate them in that manner. And also letting them educate you, pick their brain. These are boots on the ground, they do this stuff every day. They might, know of different techniques that you're not aware of that may work better. They might know more about certain products, air sealing products that they've used on different projects that work really well that maybe, maybe you weren't aware of. So there's a lot of experience there, and should definitely take advantage of that. And then there's relying on manufacturers for new product capabilities. This is big. We love to talk about what we do. I'm a manufacturer, and we're having this event here today. But yeah, reach out to folks, set up lunch and learn, set up events like this. Ask them the difficult questions. Is it going to work in this environment? What are the pros and cons of the product? Because there are pros and cons to virtually everything in the world. And really, really ask them that. Also ask them, this is an important one, ask them about the history of the product, if anything has changed, if warranty language has changed. Some products, they say, hey, great, they've been on the market for a while, now they're actually performing better than expected. So the warranty language changes and it's extended, it's improved. The inverse is also true. They can reword warranty language and reduce that. When they're not really going to put out a press release for that one, right? That's going to be more of a, okay, we're just going to change language and move forward. So when you're working with manufacturers, asking those tough questions, and definitely, we're all here to help. So really, as I said before, that's the main kind of recommendations that I've seen. The first and foremost is designing an aggressive air sealing strategy up front and communicating it across all parties. Have accountability in that air sealing detail, and educating the trades, letting them educate you. And then any products that you're using, If you have any questions about them, reach out to the manufacturers, reach out to the manufacturers' competitors, pick their brain. Yeah, and what I've heard is that this right here, this kind of strategy will lead to better results. So now we'll hop in a little bit to about what we do here at Aero Barrier. Not going to do death by PowerPoint. Everybody can see the progression of the company right there. So Aero Barrier is actually a division of a company called Aero Seal. Aero Seal was started in the early 90s and is a technology that's focused on sealing ductwork, both in residential new construction and existing builds. And if anybody has any questions about that, put it in the comments, let me know, and we can get together and talk about that later. But that product took off very, very well in the market. And then as time passed, codes got stricter and stricter, as we all know. And builders came to us and said, okay, we like what you're doing with the duct work, but what can we do about the building envelope? How can you help us, pass these blower door tests and tighten our building envelope? And that's really when Aero Barrier was born. Our product is specific to the building envelope, and we were launched really in 2016. That's when we were brought to market. 2018 is really when we hit the ground running. And as you can see there, we've won a bunch of different awards, having a major impact across the board in the single family detached world, renovations, and definitely in residential new construction in the multifamily world. So that's a little history, but what do we do? So kind of in a nutshell, Aero Barrier is an automated air sealing technology that eliminates the need to manually air seal. And we guarantee that you're going to hit whatever your air sealing requirement is, whatever that air sealing goal is. And we can guarantee that because Aero Barrier, the entire working principle is based on physics. Physics is never late, doesn't have a bad day, doesn't change its mind, doesn't miss anything. It's pretty much the most consistent thing out there. And so what does that mean? Really, we're just delivering tighter building envelopes, across the country with verified and documented results, which is very important. I'll go over that here in a minute. And it's we're reducing the time it takes for air sealing. It's all done in a single process and can reduce a lot of costs. Also help you capitalize on a lot of tax incentive and rebates that are out there, which I'll go over a little bit later. But we'll go ahead and dive right into the application. It's a 3-step application, very simple. Before I start in on step 1, I do want to let everybody know. Normally, when we come in on a project, is after drywall and first coat of mud. The only requirement for Aero Barrier is the space has to be able to be pressurized. So if you have a non-vented attic, then we can come in at rough. If it's a vented attic, obviously we need the lid on. So typically that's after a drywall and first coat of mud. Same thing in the multifamily world. After drywall and first coat of mud is typically when we come in. So envision drywall and mud. There's that 24-hour downtime, recommended downtime anyway for the drying period. That's when we would come in. So when we show up on site, the first thing we do is we prepare the unit or the house. What that is comprised of is taping off any designed openings. So that's going to be windows, doors, fireplaces, things of that nature. And then once that's done, we set up the rest of the equipment and we pressurize the space with a modified blower door, which you see on the top right there. We pressurize the space, and we're putting positive pressure into the house or the unit. We pressurize that to about 75 to 100 Pascal. Once that's done, we do a blower door test. So we get our baseline air leakage or air tightness level, however you really want to phrase it. So let's go back to that hypothetical that I gave, where we're looking to get to 5 air changes, or we could say 3 air changes, whatever that may be. We do the blower door test and we come in at 6. Okay, perfect. We know where we're at. and where we need to go. So at that point, we activate the spray nozzles, and what they do is aerosolize the sealant. So essentially turn it into a fog. They're aerosolized down to about the size of 10 micron, which is extremely small, and that's important and allows the sealant to really get back in the finest of cracks and leak points. So once the sealant is atomized into the air, that fog is created. Really, that's when physics takes over. So there's positive pressure put on the unit. The sealant is like a fog in the space. So the air is going to want to take the path of least resistance. The air is going to travel out of the unit through any of those leak points, so those cracks, holes, and crevices. As it does, it carries the sealant with it and seals those leak points up. The entire process is regulated through the brains of the operation, or the MCU, and it gives us complete control. That's important for a couple of reasons. One is obviously to make sure that the unit is getting tighter and tighter. Making sure that the seal is happening. So we get a real-time reading every 60 seconds, so you can completely dial in the air tightness level. That's important, and I talked about it earlier, to make sure that not only are we hitting that target, but we're not taking it too tight. So if our target is, in the hypothetical, it's 5 air changes, but we want to get to 2. If we took it to 0.2, it could have a negative impact on the build. So we get to exactly where you want to go as far as whatever air sealing goal you have, and we guarantee it. Once we've reached that, we shut off the equipment, go into the unit, open up the doors, and a seal report is created. This right here is the verified results I was talking about. Extremely important. There's a lot of municipalities. Well, I've never had a municipality say they wouldn't accept this for a blower door test. So and have proof of compliance at drywall and mud way before finish that you have met or exceeded your air tightness requirements. You can see here it provides the before and after service comparison in this exam, and it comes in 3 different data points: CFM of leakage, square inch hole, and air changes per hour. So before service, this was about 3,500 CFM. That was brought down to 356 CFM. That hole, if you will, that all those leak points aggregated to one hole, would have resembled a 418 square inch hole. After service, it was 42 inch. In the beginning, air changes per hour were at 8.57. After service, they were at 0.88. And all of that was done in about an hour and a half. I don't know really any other trade or building product out there that could do that. So here's some pictures of what the seal actually looks like. And I like showing these, one, because yes, they do look good. They're really good pictures of what a proper seal looks like, but they also bring up a lot of questions. And that's why I like showing them. So on the top left-hand side, we have before and after. The wires come through the drywall. You can see that the sealant accumulated around those wires completely sealed up that leak point, just like it should. But the question arises, what happens when we come in and start moving those wires around? The sealant has a plus or minus 20% flex rating. So as the electrician comes in and finishes that install, it's not going to depreciate the integrity of that seal. Then that middle section, or that middle picture, it has the before and after, nice tight seal, around that box. But you can see it kind of accumulated on the outside. So how is that going to impact our drywallers and painters? They can actually go about performing their scope of work just like they normally would. The sealant is 100% sandable and paintable. So after drywall and mud, they're coming back in, they're sanding, and they're going to paint. So everything, they just proceed as usual, no harm, no foul. And I really like that bottom middle section because it shows really the impact of physics. You see those 2 leak points in the back, as well as the seal around that wire that the sealant accumulated on it and sealed. It's Aero barrier doesn't discriminate. It's going to find and seal any leak point. You know, if there's air going out, it's going to carry our sealant with it and seal it up. So we do a lot of work with various agencies, the DOE being one of them. And the Build America study was a project we were a part of. It was really, really, really fun, to be honest, project to be part of. And you can see the statistics down there at the bottom. You know, the DOE found that that using a product like Aero barrier, you know, you're going to, you know, achieve your results in a much more effective and efficient and timely manner. One of the side aspects of this this study that I really like to talk about is the impact it had on the entire air sealing detail of the house. So the DOE, you know, after each trade came in and performed their scope work, the DOE followed up, you know, came in the house and really examined what they did with a fine-tooth comb, not only for what they did as far as, you know, what their trade was, but also what they did and how it impacted air sealing, whatever air sealing responsibilities they had. And they came up with a line item list of air sealing activities that could be backed out of a project if you're going to use something like Aero barrier. So it's a very detailed list. I have it and I can share with everyone if you'd like. But it's just really shows how using a product like Aero barrier can reduce those time and material costs. So, and then I like to show this this because it's a project that we were part of, and it shows the full impact of working with us from design to occupancy. So the Wasatch Group out in Utah, we did a project with them. They were averaging about 10 ACH air changes per hour. So we said, hey, let's get aggressive. What happens if we guarantee you come in at 1? As you can see right there, it cut their energy consumption by 50%, saved mechanical costs, and just the rebates alone, the 45L and some other utility rebates, drove 150% ROI. And here's one of the big points that I like to show is the impact on the mechanicals. So, you know, originally in energy modeling, a 3-bedroom unit required a 3.5-ton gas furnace. So we came in and said, let's get aggressive, let's come in at 1. Well, all of a sudden that 3.5-ton gas furnace dropped to a 1.5-ton VRF electric system. Mass reduction in capital expenditure up front. You know, not only did it reduce the mechanical size, but it reduced the vents, ductwork, also reduced the tenant's future energy bills. And at that 1 ACH, they're going to get a real high indoor air quality, excuse me, and reduce tenant turnover, reduce warranty complaints. So they're really benefiting of, you know, getting the maximized benefit of all the benefits of proper air sealing that we discussed earlier. So, and that's pretty much it. I know we covered a lot there in a relatively short period of time, but love to open it up to any questions.
Yeah. Thank you, Troy. It's always an interesting topic, and we always get positive feedback on this one. Definitely, I think the path forward in the industry is taking a little bit closer look at that air sealing detail. For everybody that's out there on the line, as a reminder, go to the questions box and feel free to type in any questions, concerns, thoughts, AIA numbers, and any of that jazz. And we'll get into these that are in here right now. So how does this system work for existing spaces where millwork, flooring, etc. are installed?
That's a good question. So the only spaces that we really won't or aren't a good idea to operate in is occupied spaces. So we can go from drywall and mud or rough-in, as long as it can be pressurized, all the way up to finish. The only change is the prep work that's required. So if there's any finished products in there, all we have to do is cover them up. So cover any flooring, things of that nature. Existing builds, renovations where we have to, we're renting them enough that we have to meet current code. Aero barrier is a huge value add to that, because you can't really get back in those walls unless you're tearing the wall out. You can't really get back in those wall systems to find those leaks and hit it with a can of caulk, do the manual air sealing. So with a little more prep work and an Aero barrier, we can get those existing spaces to meet really whatever code you want. So
Okay. It looks like somebody was hit with some material shortages. So how, if at any, has Aeroberry been impacted by, I guess, our material? So have we been impacted at all by shortages? If these builders or anybody wants to get on the site, like insulation and spray foam?
No, not that I'm aware of. We No, I mean, if we're talking about challenges with the supply chain because of what's been going on globally, no, we have not been impacted by that. Trimco actually, private labels are sealing. A lot of folks out there are familiar with Trimco, and we're proud to work with them. So they do a great job, and we haven't really been impacted.
Okay. How does this get buttoned into a schedule? Does this cause any scheduling impacts or timing constraints? I'm guessing is the bigger question of it.
That's a very, very good question. And the answer is typically no. So, ideally, we will be involved from the beginning, and the way we operate with our partners is different than a lot of folks out there. So, if you're an architect or a builder, let us get involved as soon as possible. We can look at your air sealing detail and scheduling and advise accordingly. We can be as involved or as detached as you want. We can recommend things that you can take out of the project. You no longer have to do this. You might want to do this, because we're focused 100% on air sealing. As far as scheduling, since we're coming in typically after drywall and first coat of mud during that downtime anyway, we're just following the drywall crew. So during that downtime, we come in, we seal the unit, we're in and out, and nobody really knows we were there besides the unit being tighter. So we're not going to add on to the schedule. What we do like to do though is coordinate with the drywall crew. Typically they're holding this up a little bit. Nothing negative on them. It just takes longer to hang drywall in a house or an apartment than it does for us to air seal it. And typically we can do, depending on, in the multifamily world, 4 to 9 units a day. Single family, 4, and that's one crew with one rig. So.
Okay. Has Aero still ever done renovations?
Yes. We've done a bunch of different renovations. I know in the Northeast we've done a lot. But yeah, it's a great tool. It's a great asset to have for those renovation projects. And I touched on a little bit earlier, but when you're trying to reach current code, because a lot of those are extremely hard. They were built 50 years ago. They were built 100 years ago. Even longer. You might not even be getting back to drywall, or excuse me, might not be getting back to studs. You might be getting back to limestone. So being able to pressurize and use physics to seal those has been a really good and effective option for a lot of folks.
What is the average cost per square foot for air barrier to a contractor?
That's a very good question, and it really varies as you can imagine. So the variables are how many units are available, because with any trade, really with anything, mobilization is going to be one of the huge factors. Also, how big the unit is, how big the house is. That's going to be another one. How leaky it is. What's your air tightness goals? That's another one. Excuse me. But yeah, so there's a lot of different variables. Typically, though, I'm including single family and multifamily. So this is going to be a really broad price range. $1 to $1.50 a square foot. Yeah, I mean, if you're looking for passive house, there's more work involved there as far as prep. If you're at finish, there's a lot of work involved. So pricing can really vary, but generally, ballpark $1 to $1.50.
Okay. How does masking over windows and doors for sealing affect final air exchanges? Might a future blower door test without masking show a higher leakage rate?
That is a very, very good question. So yes, normally there is a little bit of impact. There is. Based on, obviously that's based on the types of doors and windows that are in the building. Whether it's a really high performing window, which will not have as much leakage, versus a different type of window. So yeah, typically what we'll do though is we mitigate that. So if in the hypothetical where we went from 5 down to 2, we'll take it to 1.5. We'll take it to 1.75. If it's a multifamily build, we can kind of learn as we go, but we'll take it a little bit lower than the actual requirement, just to err on the side of caution, because we do know that when you open those areas back up, there can be air leakage. Typically, though, what we see is, since we're coming into drywall and first coat of mud, as everything else keeps getting built, the unit does get a little bit tighter. So we'll bring in a little bit lower, err on the side of caution, but yeah, that's the way we do it, and it works.
Okay. If we're interested in air sealing a project, do we reach out to you directly for consultation?
Yes. Yep.
Okay.
Reach out to me. Love working with folks on really any project. We have a couple different groups here that specialize in different areas, but reach out to me, and then I'll be able to either work directly with you, or I can make introductions to whoever on the team it would be appropriate to. Yeah, I'd love to hear from you.
Is it beneficial to do some additional prep, say on large openings with renovations on older structures? Could you describe any specific measures?
Yes. So what we say is Aero barrier can seal any gap that is a 1/2 inch or smaller. It can actually seal a lot bigger gaps than that, but it's more of an issue of time. So if you're looking to do prep work, especially on a renovation, even new construction, go around and seal those larger gaps, right? Aero barrier is not a substitute for poor workmanship. We are an extremely effective and valuable asset. We're not necessarily a miracle product though. So hit those larger openings, hit those leak points that look pretty big, but in that list from the DOE, there's things that you don't have to do, like sealing around can lights and electrical boxes, right? Running a bead of caulk behind each stud and drywall. Lots of different things, and I can walk you through that process and show you that list. But beginning, definitely, hit any large gaps. As far as windows, our sealant really doesn't stick to it. It's a strange thing, but it only sticks to horizontal surfaces. So it'll go in and seal any leak points, but the way it's formulated and how small it's atomized to, you're not going to be left with a film on the window or on the drywall. And then after it falls out of suspension and lands on those horizontal surfaces, kind of resembles drywall dust. Typically after an application at drywall and mud, nobody really knows we were there besides the unit being tighter. Obviously, if the space is finished, though, we want to cover everything. It's easier to prevent something from happening than cleaning it up. So hopefully that answers your question.
What is the largest space that Aero barrier can be used on?
That is another very good question. So to date, we did, I think it was a 250,000 cubic foot barn. But the limitation is only pressurization. So if it's a very large unit and one blower door can't force enough pressure in to create that 75 to 100 Pascal, we could put multiple blower doors on. So really, physics is the only limitation, but we've done some very, very big spaces. Also, depending on what we're looking at, if we're looking at an apartment for floor by floor, we're just looking for about passing the whole building test. We can take a look at an apartment complex, and section that off. So we can take one floor and put up a false wall and section it into 2 spaces to get that pressurization.
Okay. Are we able to purchase the equipment and get trained on how to administer Aero barrier? If so, how do we go about this process?
Yeah, that's a very good question as well. If you're interested in that, shoot me an email, or when you fill out the survey at the end, put a note in there, and I will make the introductions where possible, and introduce you folks to the individuals that will handle that for you. So yeah, love to talk to you.
Okay. And the follow-up question is Aero barrier only in-house?
No. So we have a very select group of install partners across the United States and Canada. And then we do offer support from our commercial team. So our commercial team really works on big ESCO projects. They go and, they'll seal Air Force bases. That's a perfect example. And we can use that commercial crew to self-perform seals on projects where our partners can't, where there's a gap in coverage. We also use that group though to support our partners. So if one of our partners ends up getting a very, very large project and has bandwidth issues, we can take our commercial crew to go out and support them. So no, it's not just in-house. We have a large and growing network. I love to talk to anybody that's interested in joining. And then we also have the capabilities to support you.
Well, this one's an exciting one that I'm looking forward to. Can you talk more about prep required for a renovation where the home is furnished? Is that a realistic use of this product?
I hate to say it, but not really. I have a call here in about an hour to discuss this exact topic. Because theoretically, right, it'll work because it's based on physics. But once we get down to the actual nuts and bolts of it, being able to confidently say that you can cover everything, people have pictures, there's clothes, there's towels in closets. Most people aren't willing to take the liability of delivering on a seal like that, and most occupants aren't willing to sign a piece of paper saying, basically, if their stuff gets ruined, they're fine with it. So it's not a recommended application, but I'm having a couple conversations later today. If you have something like that, let me know, and we'll see where we can go with it.
Okay. Well, that looks like it takes us to the end of these questions. So unless there's any other ones that are out there that you'd like to trickle in here, be sure to fill out the survey at the end. It's real quick and easy, letting us know how we did, but then also to include your AIA number if you hadn't placed it here in the questions portion. And otherwise, we'll wrap up here and everybody get back to their busy schedules.
Perfect. Like Billy said, be sure to make comments. Let us know how we did. Let us know if you have any questions. If you want to talk to me or anybody on our team about how we can engage, on a project level or equipment level, let me know. There's my email address, or you can put it in the comments. Don't forget your AIA numbers. And thanks again, everyone, for attending. I really appreciate your time and look forward to hearing from everybody.